An important question that comes up here is, okay, this works, but how is its performance? The answer is, well, not so good. Let's go over it with an example. If we have a 1 gigabit per second link with 15 milliseconds of propagation delay and an 8,000 bit packet, the time it will take for the transmission of this packet is length of the packet divided by the rate of the link, which would be 8,000 bits divided by 10 to the power of 9 bits per second, yielding an 8 microsecond transmission time for this packet. So, if we want to wait for a full round trip time for sending and getting an acknowledgement for a single packet, how are we utilizing the resources available to us? The utilization will be time of sending a packet divided by RDT plus that time, which will be enough for transmission and receive an ACK for a packet. With the numbers we had, this will be 0.00027. Not so good. So what we designed works, but does not use our resources in an effective way, yielding a low performance. The limiting factor in this calculation is not the medium. It is the time we are wasting in the wait for acknowledgement, which is higher than the time we are spending sending the data that is required to be sent. For example, if we start at time 0 with sending a packet with length L that takes L over R to send, the sender has to wait RDT after that time to be able to use another L over R seconds to send. We are sending one packet and waiting a whole RDT for the acknowledgement to be received. How we can change that? To improve utilization, we can pipeline. Instead of sending one packet and waiting for it to be received on the other side, we can send a bunch of packets, having some of them in flight while we are waiting for the ACKs of those sent. For example, in our previous simple example, if we send 3 packets while we are waiting for acknowledgements, we improve utilization by almost 3 times. We need 2 things to make pipelining happen: more numbers used for sequence numbering of the packets, and buffering at the sender and receiver. We are going to discuss 2 generic forms of pipeline protocols that can help us achieve this: go back N and selective repeat. In go back N, the sender can have up to N unacked packets in the pipeline. The receiver only sends cumulative acknowledgements for the packets received. The sender maintains a timer that keeps the time for the oldest unacked packet. When that timer expires, the sender will retransmit all of the unacked packets. In selective repeat, also, the sender can have up to N unacked packets in the pipeline. However, the receiver sends individual ACKs for each packet, and sender maintains timer for each packet individually. And when the timer expires, retransmits only that unacked packet.